Welcome to the subject Solid Mechanics. Today we will study the introduction to solid mechanics. First we will see what are the other names of solid mechanics. You can see here the other names usually we hear about solid mechanics are mechanics of solids, strength of materials, as well as mechanics of materials. Then what is solid mechanics? Solid mechanics is the branch of engineering that studies the behavior of solid materials under the action of forces. You can see in the above figure, one body is acted upon by different types of forces like compression, tension, shear, bending, torsion, etc. So, by studying solid mechanics, engineers can determine how much load a component like this can carry, how much it will deform due to this kind of forces, whether it will fail or not. Failure means it cannot do its intended function, or it will break. That is known as failure. How to design safe structures. So engineering is not only about making things work, it is about making them work safely. So now we can see why we should study solid mechanics. You can see three figures here. One is a bridge, other is a high-rise building, and another one is a robotic arm. What is common among all these? These all bodies experience some kind of forces. To survive these forces, they must be designed properly. The forces acting on these bodies are the same like the previous one we have seen, that is tension, compression, shear, bending, etc. Here we can see one body that is acted upon by transverse load, deflection, bending, etc. And here it's a robotic arm that is also experienced by different kinds of forces. So to survive these forces, they must be designed properly. So that is exactly what solid mechanics teaches us. So here you can see one man is sitting on a chair. So that chair should withstand the forces acted upon by the weight of his body. When he is sitting on this chair, the material of the chair is under various kinds of forces like bending, tension, shear, etc. So we should study solid mechanics to design these kind of structures properly. And here you can see a railway bridge. We know that trains travel through these bridges. It will experience lot of forces, and stresses corresponding to the forces also will be developed. So to survive these forces, they must be designed properly. That is what we are studying in solid mechanics. Whenever force acts, shape changes, internal resistance develops, material may fail. So it must be designed properly. So solid mechanics helps us how to design these materials properly. So what questions does solid mechanics answer? Can a bridge carry 1,000 vehicles? Will a crane collapse? How thick should a pressure vessel be? Pressure vessel means a vessel which has to withstand lot of pressure, like boilers. Why do shafts break? Shaft is a major part of any machine. Shaft is a long bar. It can be solid or hollow shaft, or a round cross section, or rectangle cross section. How much will a beam bend? Which material is better, steel or aluminium for a particular application? These are the questions answered by solid mechanics. When we consider the application of solid mechanics, in most of the engineering branches, it has the applications. In civil engineering, building, bridges, dams, and in mechanical engineering, shafts, gears, springs. In aerospace, aircraft wings, landing gear design. In marine field, ship hull, offshore structures. In robotics, robotic arms, manipulators, and its frames. In all these cases, solid mechanics comes into picture. Every great structure begins with understanding stress and strain. So these two terms, stress and strain, is two of the most important terms in solid mechanics. We will study about various types of stresses, various types of strains, and its effects on the material of the body. A good engineer does not guess, a good engineer calculates. So in solid mechanics, we are doing the calculations which are helpful for designing different types of structures. This is the introduction to solid mechanics. In the coming classes, we will study about various types of stresses and strains and simple problems related to stresses and strains. So wait for the next topic. Thank you.